Imagine trusting thousands of liters of water to a giant plastic tank. But have you ever wondered how it becomes nearly indestructible? Most people see only the finished tank. Hidden behind every smooth wall is an incredible journey of heat, pressure, precision, and science. What happens inside this factory surprised even experienced engineers, because every tank begins as millions of tiny plastic pellets. Those tiny pellets will soon survive scorching deserts, freezing winters, powerful storms, and decades beneath relentless sunlight. Think about this. A single household tank quietly protects one of Earth's most valuable resources every single day. Yet manufacturing one flawless tank demands carefully controlled temperatures, massive rotating machines, and surprisingly skilled human hands. Every smooth curve you see hides perfect timing, chemical engineering, and thousands of precise manufacturing decisions working together. Listen closely. The factory hums with giant motors, spinning molds, rushing air, and the unmistakable rhythm of automation. But here's what nobody tells you. One tiny mistake during molding can ruin an entire tank worth hundreds of dollars. That's why every second inside this factory matters more than you could ever imagine before the tank reaches your home. And this is where our journey truly begins, because the story starts far away from the factory floor, deep inside the world's raw material supply chain. Our story begins beneath the earth, where crude oil and natural gas become the building blocks of nearly every plastic water tank. Much of the world's polyethylene starts in countries like Saudi Arabia, the United States, Qatar, Canada, and the United Arab Emirates. Inside massive refineries, hydrocarbons separate into valuable chemicals using towering distillation columns reaching more than 60 meters high. The next step cracks hydrocarbon molecules at nearly 850 degrees Celsius, creating ethylene, the essential ingredient for high-density polyethylene. Imagine billions of tiny molecules linking together into incredibly strong polymer chains, forming material light enough to float but tough enough to last decades. Manufacturers choose food-grade HDPE, usually over 99.5% pure, because drinking water deserves materials that never contaminate its taste. Before shipping, manufacturers blend ultraviolet stabilizers, antioxidants, pigments, and processing additives measured with astonishing precision. Black tanks receive carbon black for ultraviolet protection, while lighter tanks rely on advanced reflective pigments to reduce solar heating. A single 25-kilogram bag of premium rotational molding powder may travel more than 8,000 kilometers before reaching the factory. Think about this. Every shipment must stay perfectly dry, because even tiny amounts of moisture can damage the molding process. The environmental story grows more complex. Modern factories increasingly recycle production scraps, reducing waste without compromising tank performance. Some manufacturers now blend certified recycled polyethylene into non-food contact outer layers, cutting carbon emissions while preserving structural strength. But here's the secret. None of these carefully engineered materials matter until they survive the most demanding stage inside the factory. Now the real transformation begins. Fine polyethylene powder enters a giant steel mold that already weighs more than a small car. Computer-controlled scales measure every kilogram with astonishing accuracy, because even tiny errors can weaken the finished tank. A typical 1,000-liter water tank requires nearly 25 kilograms of specially formulated rotational molding powder. Once sealed, the massive mold slowly enters an industrial oven glowing at approximately 260 degrees Celsius or 500 degrees Fahrenheit. And this is where it gets truly extraordinary. The mold begins rotating on two separate axes at the same time. The primary arm rotates about 8 RPM, while the secondary axis spins around 6 RPM, coating every surface evenly. Instead of pressure forcing the plastic outward, gravity gently spreads the melting material across every interior wall. Imagine thick honey sliding across warm glass. Molten polyethylene behaves surprisingly similar as it forms a seamless shell. Inside the oven, every particle melts together without seams, welds, or joints, creating remarkable structural strength throughout the tank. The heating cycle usually lasts between 25 and 45 minutes, depending on the tank size and wall thickness. Experienced operators constantly monitor internal air temperatures because overheating can permanently damage the polymer's molecular structure. You can actually hear the deep mechanical rhythm as giant arms rotate continuously, filling the factory with a hypnotic industrial heartbeat. But what happens next determines whether this tank lasts 5 years or 50, and that's where the real challenge begins. The glowing mold leaves the oven, but the plastic inside remains soft enough to deform if cooling happens too quickly. Instead of rushing the process, powerful fans begin circulating controlled airflow around the spinning mold for uniform cooling. Many factories carefully reduce the mold temperature from over 260 degrees Celsius to below 70 degrees Celsius before opening it. Some production lines also introduce a fine water mist, balancing cooling speed without creating dangerous thermal shock inside the polymer. Most people never think about this, but uneven cooling can warp the entire tank by several millimeters. When sensors confirm safe temperatures, technicians unlock the heavy mold, revealing the newly formed tank for the very first time. The tank still feels warm, carrying a faint scent of freshly molded polyethylene as light reflects across its perfectly smooth surface. Workers carefully trim excess plastic using precision routers and specialty cutting tools designed for clean, consistent finishing. Computer-guided drilling machines cut perfectly aligned inlet, outlet, and overflow openings with tolerances measured in fractions of a millimeter. Every opening must fit plumbing components perfectly, preventing leaks that could waste thousands of liters during years of service. Laser measuring systems immediately scan the finished dimensions, confirming consistent wall thickness and accurate overall geometry before inspection continues. By now, the tank looks complete, yet the toughest challenges still wait because every product must prove its strength before leaving. Before a single tank leaves the factory, advanced technology begins searching for flaws invisible to the human eye. Powerful AI vision systems compare every millimeter against the original digital design in just a few remarkable seconds. High-resolution laser scanners measure wall thickness with tolerances often tighter than plus or minus 1 millimeter across the entire tank. If sensors detect bubbles-thin walls or hidden voids, the computer immediately rejects the product before packaging even begins. Leading manufacturers keep rejection rates below 1%, proving how tightly every production step stays under control. Next comes hydrostatic testing, where each tank fills completely with water to verify absolute leak resistance under real conditions. Some tanks remain under pressure for hours, while inspectors carefully watch every fitting, seam, and molded connection for leaks. Then massive compression machines simulate years of heavy rooftop loads within only a few carefully controlled testing minutes. Ultraviolet weathering chambers recreate years of intense sunlight, helping engineers predict decades of outdoor performance with remarkable accuracy. Some laboratories also cycle temperatures from minus 40 to 80 degrees Celsius, exposing hidden material weaknesses before customers ever can. But here's something machines still struggle to match. Veteran inspectors often recognize subtle defects simply by touch and experience. Factories meeting ISO 9001 quality management standards document every inspection, every measurement, and every approved tank before shipment. You might think the journey ends here, but the global story behind these everyday tanks is even more extraordinary. Every year, manufacturers produce tens of millions of plastic water tanks, supplying homes, farms, factories, and entire communities across the planet. The global water storage tank market generates well over $10 billion annually, and demand continues climbing every single year. China leads global production, followed by India, the United States, Turkey, and Brazil, serving billions of people worldwide. Together, these countries manufacture well over half of the world's rotationally molded plastic water tanks every single year. Imagine every tank produced this year, standing side by side. The line would stretch for thousands of astonishing kilometers. More than 1 million people worldwide work directly or indirectly in manufacturing, transporting, installing, and maintaining these essential storage systems. Did you know? The earliest plastic water tanks appeared commercially during the 1960s, replacing heavy steel and concrete in many applications. Over the last 50 years, stronger polymers and better molding technology have doubled durability while reducing manufacturing costs dramatically. Did you know? Some premium multi-layer tanks now block sunlight so effectively that algae growth becomes dramatically less likely inside. Did you know? The largest custom-built plastic tanks can safely store more than 20,000 liters of water. Engineers now explore recycled polymers, smart sensors, and digital monitoring systems that could transform water storage during the next decade. Artificial intelligence already predicts maintenance schedules, helping prevent failures before customers ever notice a single warning sign. And after you discover today, you'll never look at an ordinary plastic water tank quite the same way again. From hidden oil reserves to intelligent factories, you followed an incredible journey that most people never even imagine exists. Every stage depended on chemistry, engineering, automation, and skilled people working together with extraordinary precision every single day. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.